Based on Bernoulli theorem. If we consider water flowing through a tube, then this quantity, the product of area of cross section and the velocity with which the water is moving, this product is called flow rate. And if we see the unit of this quantity, area is meter square and this is meter per second, so it is cubic meter per second, which means the volume of liquid flowing per second. So in a way it tells us the volume of liquid flowing per second through any cross section. So we see how much water, say for example, is coming out of it in 1 second volume wise. That is the flow rate, product of area and velocity. Now if we consider that water is flowing through a tube of varying cross section, so here the cross section is maximum and here it is minimum, water is flowing through it, it is full of water. So this product AB remains constant because whatever water is entering into this tube from this end, the same water entering here and the same water entering into this part of the tube. So it means the product AB will remain constant throughout. Now area of cross section is different, so it means even the velocity will be different. Here A into V, this product is to remain constant. Area is maximum, so it means velocity will be minimum. So velocity of water molecules will be minimum here and maximum here. Maximum here because area is minimum. So here let me say V3, V2, V1. So V3 is maximum. It is more than V2, which is more than V1. Okay. And if we can recall Bernoulli theorem, the sum of pressure, kinetic energy per unit volume and potential energy per unit volume, this remains constant for ideal liquid, liquid with zero viscosity and zero compressibility in streamline and irrotational flow. And we are taking all these assumptions that the liquid is ideal and the flow is streamlined and irrotational. It means the sum of pressure, kinetic energy and potential energy per unit volume will remain constant. And here the tube is horizontal, so there is not much difference in potential energy. We can take it same throughout. Now velocity is maximum here. It means the pressure will be minimum. So even the pressure at point 1, 2 and 3 won't be same. Here the velocity is minimum, so pressure will be maximum. So it means if we make holes in this tube here and connect vertical tubes, here the pressure is maximum, so water will go up to the maximum height here. If I make 3 tubes here, one here and one here, so water will rise because of the pressure. Maximum height of water will be in this tube because here the pressure will be maximum because velocity is minimum. An example based on it, let me consider water coming out of a tap. If you might have observed it, then water coming out of this tap has certain flow rate, which is again, let me say A into B. Now as water molecules moving downward, so the velocity will keep on increasing. If I take this distance at, and I want to calculate what is the velocity here, so it's a free fall, velocity will be under root 2 gs. So velocity of fluid particles will be more here. If velocity is more, it means the area of cross section will decrease, and this is the reason why the area of cross section of this water stream decreases as water comes downward from this tap.